from New York, it's Ask an Engineer.
Hi, everybody, and welcome to Ask Engineer. It's me, Ladyada, the engineer. With me, Mr. Ladyada on camera control. I got a fun show for you tonight. We are restarting. We are doing it. We're happening. I am vaccinated, and I'm ready to go outside and lick some things. So let's get on with the show, and I can go outside and lick things.
That's right. All right. On tonight's show, we'll talk about how we're open, safe, smart, and we'll talk about all things that we're doing for our teams and you, our community, and more. Show and tell people around the world showing and sharing their projects. Ladyada will talk about that and more. Who was on the show and tell this week, what they shared. Time travel, bunch of stuff going on in the world of makers, hackers, artists, engineers, help wanted, news from our jobs board, jobs.adafruit.com. You can post your job or you can post your skills and get a job. Some Python on hardware news, got a bunch of stuff to cover there. Some New York City factory footage, got double up this week, more than usual. 3D printing, we got a video from Noah and Pedro, and as well as a speed up. Everyone's favorite segment, DigiKey and Adafruit present Ion MPI this week. It'll be from Texas Instruments. We got new products, top secret. We answer your questions. We do that over on Discord, adafruit.it/Discord, and we're almost up to 29,000 people.
No.
But if you want to ask questions throughout the show or save them to the end, go there and join all 28,000 of us. All that and more on, you guessed it, Ask an Engineer. All right, so let's do a little biz update. First off, I want to say we are still keeping all our protocols. We're all smart. We're all doing the right thing. However, a lot of our team, if not all of them, are vaccinated or they're at their second shot or they did the one and done and then they're 2 weeks after for their second shot. Either way, it's moving along, and I want to say thank you so much to everyone on our team. This is one of the photo sets that we did throughout the pandemic of just our team, and we're all wearing masks, we're all wearing gloves. We still sanitize everything. We have good airflow. We have these MERV filters. We're doing distancing, but things are starting to change, and we adapt just like everyone else should. So things like when we're outside and we're going to the office, we don't wear a mask because you don't have to.
CDC guideline says fully vaccinated outside, don't need a mask.
Yeah.
I follow it.
And other things that we're doing, we're getting ready to restart our shows at the Ask an Engineer show, and maybe some other ones on site. But what we want to do is make sure that we're not wearing a mask and trying to, have microphones and all that. So we'll be doing our show maskless, but we'll be doing it when the rest of the team is out, unless they've been fully vaccinated as well, and they're past their 2 weeks. So we'll be figuring this out together. We've been doing this over the last year or now more. You've been able to watch what we've been doing, and we'll just continue to share how we're, restarting and recovering. We hired 4 new people, so we're hopefully partly responsible for bringing New York back. I think one of the best things you can do is hire people. If you want to see America succeed, give them jobs and give them really good jobs with good wages and good benefits. So thank you so much, team. These are some of the folks that are part of Adafruit. This is all pre-COVID photos, but I'm looking forward to being able to do another photo very soon. All right. If you want, you can help us by, purchasing stuff. And when you purchase stuff, you get free stuff.
We actually put some Picos in stock, too. So
what? Did we? We have Picos in stock? Yeah, well, that's why I played the video in the beginning, the Pico.
That's right.
But you mean if they add Pico to their cart, they can add more stuff and get free stuff?
Yes, they can also get more free stuff.
That's what you mean.
Okay, so we're no longer doing free masks with orders, of course, because our 100 days of masking is over. We still have some freebies, $99 or more. You get a free Promo Proto half-size breadboard, great for making your permanent projects off of a breadboard permanent. We also have STEM QT boards. We're filtering out different ones, adding and removing as we can get these parts in stock. So we've got about 20 or so different options. Make an account and we'll send you a different one each time. Otherwise, it's just random. $199 or more, you get free UPS ground shipping. And $299 or more, you get a free Circuit Playground Express, our all-in-one development board that runs Arduino or CircuitPython or Code.org CS Discoveries or MakeCode or many other languages. It's got all the hardware built in. It's what I always recommend people to get if it's their first electronics board and they want to learn how to make stuff with physical computing.
All right. Show and tell, people around the world showing and sharing their projects. We had a full house this week. Ladyada, who's on the show and tell this week, and what did they share?
Check it out, because we had a lot of cool stuff. We start off with Kevin W. from DigiKey. His kids are always trying to find out where the presents are hidden in the house. So he made a closet opening detector that'll text him when his closet at home is opened and also make a loud beep so he knows that the kids are rummaging for gifts. They should not be. They should wait like patient, good children. Sherry is doing a Maker Music Festival, which sounds awesome.
Yeah.
It's an all virtual event. Check out the...
And we're going to
We'll play the video.
We're going to show it on Ask an Engineer too.
Yes.
And you have to go to makermusicfestival.com, and
Yes.
it's coming up May 15th and 16th. It's all virtual.
Yes.
And if you're thinking, hey, that name sounds familiar, Sherry is one of the folks who started Maker Faire.
Yes, and she ran all the Maker Fairs
too.
too.
There's Maker Fairs happening in all sorts of different ways,
Yes.
even now.
Great. Sean M. Is running a crowdfunding campaign for the ModiBit, which is a feather wing that you can strap onto your arm or finger or head or whatever to measure all sorts of bioelectrical signals and then wirelessly transmit them to your computer, which is like super cool.
Successful Kickstarter and feather-based.
Yes. There's still more time to back it, so check out emotibit.com. It looks neat. Thanks to Sean for getting on the feather train. I think it worked out for him because it's like he doesn't have to worry about the wireless part. He just focuses on the sensing part, and we've got so many wireless feathers with LoRa and RFM69 and Bluetooth and Wi-Fi and cellular.
Yeah.
You know what I mean? He can just focus on the stuff he wants
I'm
to
not
do.
saying you have to use Feather and this good open source ecosystem to have a successful Kickstarter,
But does well.
successful Kickstarters tend to use Feather.
Yeah. From Adafruit, we've got some folks as well. Trev showed off the PyLeap demo. It's going to be a wireless Bluetooth way to programming CircuitPython boards. Erin has a salt lamp, and she's going to, she shoved some NeoPixels in it, and she's going to run it with a mag tag and turn it into a menstrual cycle ambient device, which is seems like a fun idea. JP showed off a 5-key NeoKey demo. He also, I think, showed it off on his last week's JP workshop, but like prototyping with NeoKeys to make custom keyboards that are breadboard friendly. He said it's really easy. Melissa made a motion sensing home assistant project using the Funhouse. We also have a guide for that. Scott is experimenting with taking Washington state law and putting it into GitLab so you can see diffs of laws and revisions as it goes through the legislative process. Tim made an PyPortal image generator that runs in Django and then saves it to a PyPortal Titano to change the image, and so like maybe we'll make it like internet powered. It'll be cool too. Stuart is making an automatic cubicle camera watcher where like the motor goes up and down when somebody walks by and it like takes photos and stuff. So stay away from Stuart's desk because he's gonna see you. Mark made a as seen on Show and Tell PCB badge. It's got a light sensor, an IMU, a NeoPixel, and it's a feather wing. He's gonna maybe make some more and do some more revisions, but learning a lot while getting PCBs made, which is cool. And then Danon is working on the wheelchair automation project and might be automating a small RC car to start.
Okay. Show and Tell is part of our Adafruit Live series of shows. If you're watching this right now, it's Wednesday at 8 p.m. On Wednesday at 7:30 p.m.
We just did that.
Discord. We put the link to the StreamYard link. That's if you want to show your stuff, and then links to the videos just if you want to watch it. And those are our two shows that we do on Wednesday. On Sunday, we do Desk of Ladyada, and we do it in essentially two parts. Depends on what we got going on. So part one was showing Bundlefly.
Yes. And
the other part was what you wanted to show with your new pin maker.
Yeah,
display.
I showed off this pin making software that I started off over the weekend, and Philby's working on it some more. And it's basically like how to make really beautiful pin diagrams for people who are lazy like me. I'm lazy. I don't want to make a CSV file for every board. I want it to use fritzing, and I want it to use a CircuitPython definition file, and I want it to use the Arduino definition file and auto-generate what the pin map should look like. So it's really easy for us to update the boards every time we make a change or every time we make a new board. It's very easy for us to like, just like our fritzing files where we auto-generate them from the EagleCAD. I want it to be really, really easy so we can go through and create these pin map diagrams for all of our products.
Yeah. I like how your version of lazy is to spend 20 hours coding something to help people and release it as open source and then just continue
Well,
to maintain
it
that
hasn't been
code.
20 hours. It was like 5 hours.
Oh, okay.
But in
right.
the long term, it will help because it's making SVGs is very time consuming. It's actually quite fast.
It is one of those things.
Python.
The more if you spend a little bit of time on it, you
Vector
get a lot of
graphics-
time back.
Yeah, vector graphics. It's like getting things centered, and it's really easy to do it programmatically. But as a human, it takes me a very long time to do diagrams.
And the other portion we have is
Where in the world is that part I need? The Great Search with DigiKey.
the Great Search with DigiKey, which we didn't know a part shortage was coming because we started doing Desk of Ladyada a long time ago and the Great Search with DigiKey a long time ago. But now it's the most popular dance club in New York because there's a parts. It's difficult to find parts. So every week, Ladyada uses her powers of good to show you how to find stuff on the DigiKey site. So
Yeah.
this was things for folks who do musical instruments.
Well, it seems like synthesizer folks
Synth.
like the TL074, and so I asked a synth buddy of mine for, why is a TL074 good for synth? And they gave me, a chunk of text, which I think was really a good explanation. And with that knowledge, I went and go show on DigiKey how to find op amps with similar characteristics that would be good for making LFOs or VCOs, like a low input bias current JFET inputs. We found one, I think it was like the LF357 or something. Hopefully that'll help some people out. If you're looking for a part, you can't find it, you're dealing with a part shortage, drop us a line, just tag us on social media
on
or on
Twitter,
Discord.
or you can put it in the chat, or you can email pt@adafruit.com, and Ladyada will probably add it to one of the Great Search segments, and we'll use DigiKey to find what you're looking for. Okay, next up, other shows we do. This was Tuesday, JP's product pick. I think it's the only show that broadcasts live inside of a product page, and then during the live show, you get a discount. You don't need to do anything, just add it to your cart, and it's the biggest discounts that we do. Take it away, JP. Here is JP's product pick of the week recap.
The NeoKey socket breakout for mechanical key switches. It has a NeoPixel built into it so that it can underlight your keys. It has sockets so that you can push your mechanical key switch into it without soldering, and then you can try different switches out whenever you want. I have these set up as USB HID keys, so these are sending shortcuts to my broadcast software, which means if I press 1, we get this current camera view of me in the corner. 2, it switches to a duplicate. 3 is that little product web page. 4 goes to a little product photo, and 5 clears that layer out entirely. It is the NeoKey socket mechanical key switch breakout.
All right, and then JP's workshop is tomorrow, and we added a new segment called CircuitPython parsec, and I'm going to play one of the more recent ones, and you can check out them live tomorrow, but here is the latest installment from JP.
It's the CircuitPython parsec. So here's a fundamental thing. How do you read the input of a digital pin? So if you look here on, I've got a Metro Express right here, Metro Express M0. There's a bunch of pins here, general purpose input-output pins, GPIO. And sometimes we want to use these as input pins, so we want to be able to read things like switches and buttons. In this case, I have a little button, little breakout board for a button, plugged into ground on one side, and I have it plugged into a digital pin, pin D7 on the board. If you look at my code here, I'm importing the board, which gives me the definitions of what pins are connected to this board and what they do. I'm importing this library called Digital I/O, and specifically I'm bringing in the sections of the library for digital inputs and outputs, for direction, which allows me to say whether I'm going in or out, and pull, which is using an internal pull-up resistor. The next part of the setup I have here is actually just so I can see an LED blink, so we'll ignore that part. So you can see here in this section, I'm setting up one of these pins as the button pin, and I'm calling that a digital input-output on D7. I'm setting the direction of that pin to be an input, so it's reading from an external thing inward. And I'm setting that up to use the internal pull-up resistor on the chip. And then my code for doing something interesting with this pin is simply the main loop of the program where it says, while true, what happens? We change the value of that LED to be the opposite of the button value. So when I press that button, the button value is going essentially from high to low, and that's sending my LED from low to high. And this is because of the nature of the pull-up resistor. So there you can see LED value equals not button value, and that means we get to click on the button and light up the LED. Now, of course, you could do many, many more interesting things with it than that, but this is the very beginning sort of foundation of how do I do stuff on my microcontroller, and one of the key things you want to do is interface with an input device from the outside world, and for that we use the digital in. And that is your CircuitPython parsec.
So once again, don't forget JP's workshop is tomorrow. Time travel. Look around what's going on, events, news, some videos, and more. Sherry was on our show and tell, and she talked about the Maker Music Festival, be part of the virtual event. It is May 15th and 16th. Go to makermusicfestival.com, and we have a 1 minute 46-second video with all the types of things you will see in here. If you've been to
It's
Maker
amazing.
Fairs, you've seen this before, and Sherry is one of the people who runs the Maker Fairs. So let's take a look, and we'll see you on the other side.
Perioden Text.
Okay, and yesterday we did a fun site takeover thing. We changed our logos on the site and celebrate all sorts of events. Yesterday was May the 4th be with you. So if you're a fan of Star Wars, you can take a look at all the projects throughout the years, over a decade, I think by now, of projects that people built in the Star Wars universe using Adafruit stuff. So check out 3D printing projects, electronic projects, and more. We even have things like the prop wing that is used in all sorts of sabers. Also on our blog for this entire month, it's Asian American and Pacific Islander Heritage Month 2021. Every single month we're celebrating all sorts of folks, the entire spectrum of humans. There's a month dedicated to it, or a day or something, and we try to make sure we get their stories out on the Adafruit blog. We're just an electronic site, but we have a platform, so we try to get all these voices out there, so check it out and tune in and read. Other bits of time travel, this is a little mini video that Phil B put together. I think it was NeoPixels and Dot
And
Stars.
Dot Stars. Take it away.
NeoPixel and DotStar LEDs, they look about the same from here, and everybody loves NeoPixels, so why consider DotStars? Ease of driving them is one reason. NeoPixels have one wire. Short pulses are zeros, long pulses are ones, with a frequency around 800 kilohertz, give or take. Most, but not all microcontrollers can do that reliably, or there may be trade-offs. DotStars add a second pin for control. Now there's a separate clock and data signal. For each clock pulse, one bit of data is read. 1, 0, 0, 0, 0, 1, 0, 1, 0, etc. And the timing from bit to bit, fast or slow, it makes no difference. If you've got two pins, then any computer and any language can control this. Anything! So the name DotStar. It's a play on words. It's like a wild card. .star.
All right, next up, we posted a photo and we said, well, we're going to be putting these banners and stuff on our website and more. And we said, well, like we have some ideas, but maybe the community has some ideas. And we said, well, let's do a caption contest. So across Twitter, TikTok, Instagram, Facebook, our blog, LinkedIn, I think that's all of them. There was over like 200 or so. So we took a look at all of them. Our team decided here's some that we think are really funny. These are ones that we can use. And before I read off the winner, I wanted to read some of the ones that were really good, really close, but we can only have one winner in this one. So one of them was 1234 Adafruit Pi 2040. Close. The other one that bubbled up was the 4 horse boards of the Maker Apocalypse. Another one was Eeny, Meeny, Miny, Mo, Raspberry Pi chips, PIO. If CircuitPython starts to code, display it all with Adafruit IO. Another one was 4 slices of 2040 Pi. This is one of my favorites, but I'll announce the winner in a second. One microcontroller to build them all, and in the darkness code them. And then the one that won happens to be on Instagram. We had over 100 comments there, and the winner is congratulations, GBean 2007 Fantastic Four. Because
straight to the point.
Because everyone was picking their favorite board and all that. People were saying these are fantastic. There was play around 4, but Fantastic Four was the one that we picked. So
nice
we will reply to you on Instagram, and I guess hopefully you watch the shows or whatever, but we'll get a hold of you, and you can pick one of these Fantastic Four boards.
Oh.
All right. Adafruit IO has an update. It's our free service. We also have a pro version. The update is you should sign up for the Adafruit Internet of Things monthly newsletter. It goes out like tomorrow or the next day.
Yes.
But you should sign up tonight, and here's a preview of it. It has all the latest things from Adafruit IO delivered to your mailbox. Adafruitdaily.com is how we do it, because we don't spam, we don't harvest your email. It's a completely separate site. So you can't even say, hey, I ordered some from Adafruit, then you start spamming me. We don't do that. We have a completely separate site. So put that in adafruitdaily.com and unsubscribe anytime. But if you want to see the latest and greatest hardware in IoT.
And send us links too if you have ideas.
Yeah.
If you
All
see
right.
stuff around the internet that you think would be cool.
Next
Doesn't have to
up.
use Adafruit.
We have our daily dose of Colin, Monday through Friday. Here is some of the latest Colin's lab notes.
When I hear the word piezo, I think of a little fragile disc that can convert mechanical pressure into a small electrical charge, which is cool. Piezo discs are amazing. But I was not aware piezoelectric material could be made into a thin and flexible film. But this 2-foot piezo ribbon sensor has enlightened me. So what do you do with a flowing silver strip that senses mechanical stress? Well, I'm sure there's some impressive biohacking project it would be great for, but get this. Electronic wind. When a feather board's too big, but you need more pins than a cutie pie has to offer, Itsy Bitsy is the go-to option, the happy medium. And Itsy Bitsy is now available in the tasty RP2040 flavor, which means it has a lot more pep in its step and tricks up its sleeve. A dual Cortex M0 Plus running at 125 MHz, 264K of SRAM, and 8 megs of flash. In addition to standard niceties like the built-in NeoPixel, the Bitsy can speak 5-volt logic on pin 5, so there's no need to add any additional level shifting hardware, which is nice. And bonus, that boot select button can be read and used within your code. So I don't have to add a push button, but I do have to figure out how I'm going to use 16 channels of pulse width modulation. Let's take a moment to pay homage to the potentiometer. It's easy to forget how often we use them. They're at the heart of most analog input devices. Look inside and you'll find a pot, often in the form of the familiar rotary potentiometer. Like, really often. Thank you, Potentiometer, for all you do. The following is a public service announcement, perhaps most directed at myself in the past, but maybe you'll find it useful. Breadboards, as convenient as they are not perfect for everything, like, say, high-power circuits. Opinions differ on what the maximum is, but personally, for anything over 5 watts, I'll move to a piece of perf board. Breadboards, especially the cheap ones, can actually melt. And then there's sensitive circuits. These spring clips inside of a breadboard create extra inductance and capacitance. So when you're building that precision oscillator, things might get a little unreliable and weird. And the same goes for high frequency stuff. In my experience, anything over 1 megahertz starts to get kind of wonky on a breadboard. So stay sane and use the right tool for the job, which, FYI, might be a proto board. Just saying. When's the last time you just played with something for the fun of it? Well, magnet film is a good something, and it's very science. Magnet film contains tiny capsules filled with oil and flakes of nickel. Magnetic fields move these flakes around. When they're lying flat, they reflect light and appear bright. And when they're standing up, they look darker. So that's neodymium magnets. How about we try a magnetic work mat? The entire surface is just rows of alternating polarity. You can even use them to comb and rearrange the nickel particles. Of course, I can't ignore these small spherical magnets. Lovely.
All right, helpwantedjobs.adafruit.com. 2 latest jobs as a product designer, engineer, and a full-stack developer. These are, I believe, remote positions over in India, and you will be able to apply through our jobs board. These are all the ones that we look at, make sure that they're legit and all that, so do check it out. And then also, if you have skills, you can post your skills there and get a job, or if you're a company looking for makers, engineers, artists, and more, you can post the job on jobs.adafruit.com. Next up, it is Python on hardware time. All right, so I've got an extended version. I'm just going to do a quick recap of some of the things from the newsletter, and then I'm going to talk about, I normally do a rant and stuff like that.
Yeah.
But there's always like a moral of the story, or there's like, hey, this is like the next action to do good. This is a good one, and all coincides with happy birthday, MicroPython. It's their 8th birthday, turned 8 years old on April 29th. 2013 was when Damien, the creator of MicroPython, wrote the first line of code private before anyone knew about it, before it was even called MicroPython. Now, MicroPython is used in all sorts of microcontrollers and more. Version 1.15 was just released 2 weeks ago with some great features. So in the newsletter, you can see all the things that are going on in the world of Python. Python Software Foundation just added Microsoft as a visionary sponsor. Adafruit is a, I think we're called participant sponsor. So we're sponsoring PyCon this year. You can check out Tom's Hardware with a review of the Adafruit Itsy Bitsy RP2040. They've been doing all those. Scott has a deep dive, does these each week. You can see all sorts of projects. I'm just going to highlight a couple before I go into the MicroPython birthday stuff and neat story about open source. This I thought was cool. This is a Black Panther smart display alarm clock, and it uses Marvel's API. I didn't know Marvel had an API,
That's cool.
and I don't know why I didn't know this is like.
Of course I do.
So, anyways, check it out, and you can get like all the neat stats and all sorts of things from the Marvel universe. Todd's still working on this MIDI controller. We've got this Trinky Dance Party. This is using colors and all sorts of things with the Adafruit Neo Trinky and CircuitPython. A lot of these are CircuitPython, the visual thermometer. This is a theremin. Here's a really neat pool temperature project that you have the temperature of the pool, sends it to a mag tag on the refrigerator, and that's when the grandkids will then know, and this is the story behind this, when it's okay to go in the pool because that'd be a certain temperature. And this is on Hackaday.io. So lots of good stuff. So many projects, too many. It's getting to the point each week that it's nearly impossible
So go check it
to
out.
keep track of everything. Lots of keyboard projects this week too.
Yeah.
But you name it, it's being made in Python. And I think we're at a good spot where we could talk about, like, one of the many successes in open source, because people are like, why do open source? So here's this week's talk I wanted to do.
So you're gonna get like a little thing. It's like Phil's talk.
Happy birthday. I had an article thing at Make. It was called like Phil's Soapbox. Happy birthday, MicroPython, 8 years old. And one of the cool things about MicroPython is it's open source.
That's right.
And there's lots of
It's
ways.
very open source.
Yeah, there's lots of ways you can support an open source project or company or individuals.
Oh, you mean like giving money to the FSF?
I wouldn't suggest we discuss the FSF during this segment. We're going to stick to
You mean there's other
MicroPython.
ways to support open source?
Yeah, so
Great.
one of the ways you can do it is I just did a very quick search on our blog. So we have 883 posts dedicated to MicroPython. There's a lot more, but that's just the top. And you can search via Google site specific and see there's probably thousands by now. And so one of the things that you can do when you want to help open source is get the word out about good things they're doing. So more developers get involved, more people who want to do documentation, more people who want to do events, more everybody. There's a role for everyone in open source. That's one of the things you can do. And if we were to have little checkboxes, check, we did that. But this is all stuff that everyone can do. Here's the other thing. Let's say you have an electronics store like Adafruit.com. Well, Damien and his company made the Pi board. We stock the Pi board. We buy the Pi board. We send Damien money.
That's right.
And then we get Pi boards, and then we sell them to you.
And we sell the accessories too.
So that is a way to support.
Yes.
So you could get the word out, bring people together, write about things, celebrate stuff. You could physically buy stuff. Here's another thing you can do. Oh, and we also have some of the accessories, by the way. Yeah. And you could go to our website and you could check out, Pi board and MicroPython Pi board, all that stuff. And you can buy them right now. Other thing we did was like, well, this is kind of cool. Let's make a sticker. And this was they had artwork, but we said, well, hey, we can make the artwork print ready, and we'll make stickers. And one of the things we did with the sticker, because you're like, oh, you're just making MicroPython stickers. What are you going to do with all that sticker money, Adafruit? Well, we have this we have this notice that's very specific that says, each sticker purchase helps MicroPython. Well, the deal is not a lot of people buy stickers. Some people buy boards. Some people read the blog. But 8 years has gone by. So we saw that this year, MicroPython has sponsorship enabled on GitHub. And the way it works is you give them money if you're on GitHub. And right now I think they're waiving the fees. And you could be an individual sponsor. You can now be an organizational sponsor. And basically what it does, when you give them money and they have goals, they want to get to $5,000 a month, continued maintenance of the software, recruiting additional maintainers of things like GitHub issues, funding purchase of development boards for new platforms, offering bounties for fixing bugs, investing in opportunities for paid development and paid documentation improvements. So this year was a different year because there's sponsorships on GitHub. You can sponsor one time. You can also sponsor as an organization because it's all new stuff with GitHub. 2 years ago, we did a donation. We didn't talk about we didn't do anything. We just said, hey, Damien, and we just gave him the money.
Yeah.
We said, happy 6th birthday. Here's $6,000 to help the development with MicroPython because we build on top of MicroPython just like other bits of open source.
That's right.
And that's where the core of CircuitPython comes from because we do things like make hardware and we make enough money to do other things with it, like give it to our employees.
Right.
And give it to other folks and donate to folks. So this is success in action with open source software and hardware.
Yes.
So what we did was we looked and we said, hey, look at these sponsors. There's about 50 people that are sponsoring altogether. They're about 25% of their goal. And I was looking at the way GitHub allows you to do stuff as an organization now. So I flipped me from Phil to Adafruit because it says, hey, do you want to sponsor as Adafruit? And I'm like, yeah, that's what we want to do. We want to sponsor as Adafruit. And I hit the button and it said, congratulations, you sponsored MicroPython, $5,000. So money's tight for us, just like it is for everybody else. We're recovering, we're trying to hire. But we had enough budget. We did a PyCon sponsorship, and this is our MicroPython sponsorship. And I got this cute little email with, this is Mona, the Octocat.
Happy Mona.
And that's $5,000 donation, and that means that they hit their goal for the month. Now, it doesn't show in the progress meter the same way because this is a one-time. So what we're hoping is other people or other organizations matches Adafruit and says, hey, I'm a company that bases my stuff on MicroPython too.
Yeah.
I'm going to take care of one full month. bang,
Bang.
go in there.
Go.
So we did it, and this is where they're at with the recurring ones. They're 25%, and then we did a one-time for 5K. Now, the cool thing about all this is people notice, and this is a tweet we saw, and we're just like, whoa, that guy sounds familiar. Well, that was Nat Friedman, the co-founder and CEO of GitHub, and said, very cool to see the fine folks at GitHub give $5,000 to MicroPython project with GitHub sponsors. Happy 8th birthday, MicroPython. That's pretty cool.
Yeah, pretty cool.
So
Good work.
this is how open source can work. So, some folks would say, well, there's no business model in any of this. You can't possibly sell hardware, software, give it all away. Can't do it. And like, oh, there's different versions of everything. How come there's not just one version? There all these things.
Yeah, but you say.
We're just proving there is a model that can work.
Correct.
And so we're hoping that other people get encouraged, consider sponsoring MicroPython. You can buy hardware from Adafruit, the boards. You can also buy our hardware that has CircuitPython on it. Or even something like Make Code or Arduino, because you know what we're going to do with some of the money? We're going to give it to MicroPython. And so that is this week's,
Phil's soapbox.
rant, soapbox, whatever.
I like the soapbox.
But if you're building your stuff off open source, there are ways that you can do things. And most of all, we're all just not like avatars and robots that do pull requests. We're humans. I think it's a good way to show that you appreciate what they're doing. Of course, contribute to the code. Of course, do things like documentation. Of course, be in the community and be helpful. But if you have some way to sponsor in some way, please consider doing it.
Yes.
Happy 8th birthday, MicroPython.
Happy birthday to you.
And that's Python hardware news.
Thank you, Blinka. Thank you, MicroPython Snake, whatever your name is.
Okay, open source hardware news. I was going to put this in the Python news, but there's a lot going on this week. This is a very cool thing. Python Foundation announced they were doing this in March. They changed the repository from master, which is an outdated term, to main, and GitHub has made that as the default on programs and branches and all those things. It's now the
All new
default.
repos you consider it as a default.
Yeah,
We do.
Yeah, and so if you're wondering how they got to there, why did they do that? There was this message, and I thought this was neat to read because we do similar things. They said, yes, this is a political decision. Very many decisions are political. The existence of open source project is inherently political. The decision to try to make Python more welcoming, more open, more helpful is also a political decision, one that the steering committee, Python steering committee feels is absolutely necessary for the long-term health of the Python language. Not wanting to be bothered by political decisions is a political decision. It's a decision that you're happy with politics as they are. I'm afraid you can't avoid politics.
It's a good meta conversation.
It's exactly for a lot of things that are going
They're
on.
right. Your reaction to a decision is a political decision.
I've learned,
Deep.
every year of being alive, inaction is worse. Is one of the worst things you can do.
Yeah.
By not doing something. So this is really neat. It's now flipped over. They did it 2 days ago, and the other part of the message on the mailing list they had posted is, while you may feel the benefit of this change is small and it'll lead to no real impact, we believe that there is little cost to making this change. We believe this change, while minor inconvenience to some, helps demonstrate our commitment to acting in the best interest of Python's future. Failure to make a small sacrifice such as this signals that the Python core development community would be unlikely to undertake real change for greater benefits. This isn't happening because of GitHub. Microsoft made a political decision. It's happening because it is incredibly easy to make this move now, and many projects have already done so, and reflects badly on any project not making this change. Speaking for the whole steering committee on this. So I have resources. Linux did this. Red Hat did this. For pin naming, Open Source Hardware Association has a post about some possible naming changes. We had already changed some names, replacing some music terms, and then the original thing on GitHub. And we had changed to main last year.
Yep.
You could check it out. And so we do have some libraries that we're still working on. We'll get there, but I think one of the things is you just have to see progress, little bits every day. Even though it's just a drop in the bucket, you get enough drops together, you got a big old ocean. So that is good stuff. Thank you, Python Steering Committee, for doing
Okay.
that. More open source.
They're very well written statement, by the way.
Yeah.
I know a good well written statement when I see it. I've seen a lot of really bad ones.
Turns
this week.
out when you talk to a bunch of people together, you tend to have better statements for the world
Yeah.
than just like posting stuff without checking with anyone. Anyways.
All right, next up.
We have 2,471 guides. Lady Ada, what's on the big board this week? I have it in 2 parts.
Okay, well we have a bunch of updated guides. Katney's working on templates for RP 2040 and for our essentials guide. So trying to unify our documentation, but also customize it for each board. So we have the pin numbering or the schematic drawing for that particular board. So the Cutie Pie RP 2040, the Feather RP 2040, and the Itsy Bitsy RP 2040, the Titano guides. They're not new guides; they've just been updated to add these new templates. Melissa wrote a guide on a motion-activated outlet with the Adafruit Funhouse. You can see there the mag tag. It's a mag tag. The Funhouse on the fan. When the PIR sensor has a hand in front of it, it turns on the outlet. So it's a really good tutorial on how to control appliances when safely with an outlet control. We've also Melissa also published guides on the Adafruit Funhouse in general. I worked with her on it. Katney did too, on the pinouts and code examples and getting it set up, as well as a guide on using CircuitPython with the Funhouse. Carter did a big project this week. He ported Blinka over to support Pico U2IF, which is a special firmware that runs on a Raspberry Pi Pico that turns it into a USB to hardware converter chip. So you can use it for I2C and PWM and NeoPixels and SPI and like I2S even, and a bunch of analog inputs, all sorts of hardware you want to connect. You can then read that data into CPython. We already have support for this in Blinka, so this was just another board to add. And we thought it was a great one because we mentioned Picos are in stock and they're $4. So how can you beat that?
Yeah, do you want me to go to the next set?
Yeah, sure. What's I covered that. Those were already there.
You got those?
Yeah.
You got these?
I did them all.
You did them all.
Yeah.
Okay, we're gonna go straight over to the manufacturing video.
That's right.
And it would be New York City factory footage. What else? Some footage
Construction.
of the Disney headquarters.
Oh, that's a nice lighting change. Oh,
Yeah,
rain.
it hailed.
We've got some wets.
So we got some rain there.
got
yeah.
some wets, got some digs.
All right, 3D printing. I'm going to play these back to back. First one is the extremely popular and photogenic lemon keyboard.
Lemon and lime.
And then we're going to do a speed up, still celebrating May the Force be with you. So there'll be a speed up from
Or Baby Yoda.
a Baby Yoda.
In this project, we're making a custom keypad in the shape of a lemon. This keypad uses mechanical switches with 3D printed keycaps fitted on top. It's set up to be a USB keypad for controlling your media like iTunes or Spotify. It uses the HID library for CircuitPython so it can do keystrokes and macros. The electronics are housed in a 3D printed case with all the parts snap-fitting together. This Adafruit Cutie Pie features the RP2040 chip from the Raspberry Pi Foundation. It's a tiny CircuitPython board with 11 GPIO, 8 megs of flash, and a STEMMA QT connector. Paired with mechanical switches, we think it's the perfect board for your small keyboard projects. The keycaps feature little posts that are press-fitted into the stem of the mechanical switch. It's compatible with any Cherry MX or Kale switch, so you can use the ones you like. The code for this project uses the USB HID library for CircuitPython written by Dan Halbert. The buttons are listed in an array with the pin names matching the GPIO. The key commands are listed in another array with the pins ordered chronologically. Key presses are printed in the REPL so you can plot each switch to your desired key code. With CircuitPython, it's really easy to make custom USB HID projects. Check out the Learn Guide for everything you need to build this project. You can get the code and libraries by downloading the project bundle. It's the big blue button right above the code embed. Bundlefly will grab all of the code and libraries, but also any project files like fonts and images. All of the files are bundled in a single zip, so you'll have everything you need to run the code. The board shows up like a USB drive, so you can just drag and drop all the files. Thanks, Bundlefly. We designed the enclosure in Fusion 360. If you'd like to modify the design or make your own, we have 3D models available to download from GitHub. Using the fuzzy skin feature in the Cura slicing software, you can give your models a really nice texture. With fuzzy skin only on the outside, you can make sure the internal walls are kept nice and smooth. We used yellow PLA filament, but you'll be happy to know all of the parts can be 3D printed without any supports. So next time life gives you lemons, we hope you're inspired to try CircuitPython.
Alright, if you want to learn how to make all this stuff, every Wednesday 3D Hangouts with Noah Pedro. It's time. DigiKey and Adafruit present Okay, this week's Ion MPI new product, Ladyada. It's from Texas Instruments.
That's right.
What is it?
I love Texas. They got great chips and they got great barbecue. This week's IMPI is the TI BQ 25792. Have it written down so don't forget it. The BQ 25792, which actually wasn't on the DigiKey new product section, but is such an awesome chip. I saw it, I think, through like the TI RSS feed, and I was like, okay, I gotta cover this because this is such a great charger chip. So this is the eval board. So you can pick up the eval board from DigiKey 2. They also have chips in stock. I'm also trying to pick NPI chips that you can actually buy at the time of viewing, because I know there's a global chip shortage. But they do have them in stock, so that's why it's this week's INPI. So the BQ25792, here you go. So this is a chip. This is a simplified schematic because there's a bunch of control pins that aren't shown here. Basically, it's a buck boost battery charger. You can charge 1 to 4 series batteries, 4S, so that's 4 batteries in a row, just like I think 18 volts or something. It's a buck boost converter charger, which means that you can charge it from almost any voltage. And then it even has like an on-the-go mode where it can like buck boost out as well. So it's kind of like an all-in-one like power charger manager updater. And it's got great standalone and I2C support. It kind of like does everything. Like I've looked at a lot of chargers and there's always like, here's a simple one that just does 1S batteries and only charges at a certain rate. But this one was really like, it's quite a delicious chip. So it's can support USB PD. Note that it doesn't do the USB PD negotiation. You would have that done by a separate chip, but if necessary. But it does support very high voltage input from 3.6 to 24 volts in. You can choose 750 kilohertz or 1.5 megahertz switching frequencies for the buck and boost. You can configure the charging current over I2C or with a resistor, so you can kind of like a rough charge current with a resistor, you can, as rough as your 1% resistor is, or you can program it in over I2C. There's max power point tracking support because it's a buck boost, so it has like input voltage and input current limiting, but there might be something that like sometimes the voltage going higher or the current going higher like may change the efficiency overall. So it tries to find the highest efficiency. And it does have D plus and D minus lines to detect USB chargers, like have like the Apple resistor charger divider thing where the voltage on the D plus and D minus pins, when not connected to a host or a peripheral chip, can tell you basically what the charger is capable of. I recently started using BQ charger chips. So this is our solar LiPo charger, USB, DC or solar, using a BQ chip, not this one, but this one's I think a linear charger. And it works great. I mean, I really love these BQ chips. TI's been making LiPo and other battery charger chips for a very, very long time. I've noticed recently they really stepped up their power supply and battery game. Really, like every time I look at a chip, I'm like, they really thought of everything. Okay, so the first thing is it has like the standalone mode where there's an iLimit pin and a prog pin. And you can see here by picking a certain kind of resistor, you can you hard code in the number of cells. So it's 4.2 volts per cell. So it's like one cell is 4.2, 2 cells is 4.8, and then up to 16.6. I tend to use 3.7 volt, 4.2 volt, single cell configurations the most. But I've noticed a lot of people who do robotics or drones, they tend to use 2S or 3S cells. So this would be perfect for them. And one of the nice things is that it supports USB or DC inputs. And the thing that's really frustrating about DC linear chargers or even, buck or boost chargers is like you don't know when you plug in a DC 2.1 millimeter outlet, something into your outlet, the wall wart. You don't know what you're going to get. Like there's wall DC adapters that give you 3 volts up to 24 volts. Like you have no idea. And so that's what I really like, that it's so zen. No matter what you give it, it gives you the right voltage out once you set the output you want. So it has, like I said, a buck boost converter. So this is, for example, the graph of using a 1S battery, so about a 4 volt battery, and it shows you here the V buses from 5 volts at the top all the way down to 20 volts. So yes, the efficiency goes down, but that's okay. I mean, which makes sense. It's less efficient. You're going to lose some efficiency with the buck boost, but you can still charge from a 20 volt power supply. Like it's totally fine. Likewise, here's a 3S battery charger, and you can see it's the yellow line at the bottom is 5 volt is where it's trying to boost up to about 12 volts. So it's not as efficient. And then 9 to 12, that's closer to the actual battery output voltage. You're gonna get more efficient. And then, 3S is kind of nice because like 15 or 20 volts is a little bit above, but you're not overdriving the buck boost converter. But basically, what I like about this, it shows your input, your output, it doesn't matter. It's all possible, and it'll just do the right thing. It has dynamic power management, which is what I use in the solar charger that I showed you earlier. So if you have a wall adapter and it can supply 1 amp max, but you're trying to charge a battery and it likes to be charged at 2 amps max, like you don't want to draw 2 amps from the wall adapter because you'll collapse the voltage. Like the wall adapter will overcurrent and shut down. So you have to be very careful. As you see that voltage drooping, you want to stop before you overload the adapter, overload the USB port. The cable can have a voltage drop as well. So it uses this dynamic power management, which checks the input voltage and slowly turns down the current as the voltage starts drooping. There's also this input current optimizer, which I think you could turn on over I2C, and this actually does like more of a max power point tracking thing, because again, sometimes the voltage going up or down, just because it's going down doesn't mean it's going to be less efficient, and going up means more. Like it can be either way depending on, like you saw those curves, like it kind of depends on your input voltage point and your output battery voltage. So this is kind of neat. I want to try this because I wonder how it would work with solar, because again, solar is so specific in particular about getting that max power point. But this does seem to kind of like noodle around the voltage and current to try to find that max power point. So this will get you better, faster charging, because you're going to get the max amount of power out of your power supply. It also does, like I said, it can do USB D plus D minus detection. Depending on the voltage dividers on those 2 pins, it can give you a hint about what the power supply can give you. And so this, if you connect the D plus and D minus pins, it'll do an analog digital conversion on those and kind of try to figure out, like, okay, what does the power supply think it can provide? Even if I could take more power out, I'm going to limit it to what it's telling me is the max. It's a polite way of working with USB wall adapters. And then, of course, there's this I2C interface, and so you can use that to read the analog digital converter inside. So, like, everything from like the temperature to the battery input voltage to the power input voltage to the current for charging and the current for the buck boost converters, all measured, and so you can read that whenever you want to see what the status is and like do an analysis of how your battery life is going on. So that's the I2C port, which again is optional. You don't need to use it. It runs perfectly fine in standalone mode. And finally, I thought this was kind of nifty, although I'll be honest, I've never used this myself, is that you can put it into on-the-go mode, where instead of using the buck boost to charge the battery then like goes backwards and is buck boosted to an output voltage that you set over I2C. So if you want it to be like a 5-volt output or a 12-volt output boost converter or buck converter, and especially if you're like kind of in the middle of like between what the battery nominal voltage and peak voltage is, this could be kind of neat. You don't have to use it. Of course, you can just take the system voltage out and it'll give you the battery voltage. Of course, it does power sharing. So if it's powered over DC, you'll get, it won't drain the battery. You'll just get power from DC. And then when the DC is connected, it charges from the battery instead. And this is just some efficiency showing that you can get about like a half an amp to an amp from the on-the-go converter. So yeah, kind of like an all-in-one, like whatever you have. If it's got a bunch of LiPo batteries, this charger will probably do the right job for you.
All right, everybody likes this and everybody wants this.
It's a great chip, and it's in stock. It's not too expensive. It's a couple bucks.
Here's the part number. If they want to search, they can read this here, but you could also probably just search for it.
The BQ25792. So it's in stock, which is, again, I'm trying to only suggest things in stock. They have a couple thousand in stock. I'm definitely going to pick some up. It's a great chip. It's available in QFN. It's not too hard to put together. It's non-BGA. And not too many pads and not too many connections. Like it's bare bones. It's spare, but it's very complete.
Okay, before we get into new products, we're going to mention one thing. AdaBox is shipping. Some people are getting notifications.
Yes.
If you didn't get yours yet, don't worry. And they should be to you in the next couple weeks, and we'll have our unboxing pretty soon. Sign up. You will be able to possibly get one if we get through all of the people who have moves or credit card changes. But most likely, sign up so you get notified for the next one. And don't forget, we will not be doing international ones going forward. We'll wrap up all the ones that we did do that are on gift certificates or gift Ada boxes. But we have to put international on pause because everything is crazy with how international shipping works right now. So we're just going to focus on the domestic ones. We'll get back to those later. We'll be working with our carriers.
All right, let's
because
get
the
to new
costs
products.
are new products.
New products. It's new time. New products.
All right, first
Got a
up,
theme song
it's
now.
a revision.
That's right. We've got an update to our e-ink bonnet. It's the same size, the same kind of display. It looks the same, but it's a new chipset. Now has the SSD 1680. The previous chipset was discontinued. What does this mean? Just check our example code. You'll want to select SSD 1680 as the chip that it's communicating with. If you're using our old code, the firmware is different. So you'll have to recompile or re-upload your code for any e-ink bonnet projects. But we have support for it, and it's just like one line change. Very easy.
Next up, wires.
We've got some wires. So for some kits, we like to sometimes include a small number of wires. So this is 10 extension cables. You've got one of every color of the rainbow. You've got little male plug headers on one end. You got female socket headers on the other. It's about 12 inches long. It's very petite. It's only a couple bucks. Great when you just want to like make something longer.
Okay, next up.
Okay, next up, we've got, by popular demand, these reverse mount NeoPixels. These are SK6812 NeoPixels, and they've got like the legs bent out. You see, like usually they're bent under, but they're bent out, which I thought was a cool hack to turn these into reverse mount NeoPixels, as shown here on the Neo key. So what you do is you cut a hole in the PCB, and it comes on a little piece of tape. You put it so the LED shines through the PCB, and now you've got a reverse mount NeoPixel, so the top is perfectly flat. A couple of reasons you might want this. One, again, you need a totally flat PCB here because there's a thing that goes on top, and you don't want it to be in the way. Also, can simplify your builds because you only need a single side assembly. So I can show on the overhead what this looks like because it's being used in a new product. So this is the reverse mount NeoPixel. This is the reverse mount NeoPixel here. And then this is what it looks like. So as I twist this, you can see it's a nice bright NeoPixel. It's just like any other, but it's got those big flat legs. And just don't forget, you need to have the cutout. This isn't like some LEDs where they have like a J lead and they sit flat against the PCB. These you actually need the little square cutout. So just make sure you do that. If you need a footprint, check out our NeoKey PCB on GitHub. You can use that as just delete everything else, and you can get the footprint and the cutout that we've used. All right, next up, you have something that's wet and you want it to be dry, or you have something dry and you want it to be wet. Well, we have a very simple, inexpensive water sensor that you can use. Here I've got it hooked up to an Adafruit Funhouse. I also have the same demo I'll show on the overhead. It's very simple, and I got one of these, and I'm like, this actually works really well. Like, I don't have anything to improve on it. You give it 3 to 5 volts power, connected to ground, and then there's a signal output. Now, I will say, in theory, this is an analog output. So you see, like, as I put my slightly damp human finger on it, this gauge goes up. But if you actually, let's say I have a little bowl of water here. Okay, water bowl. And then I put I put a little bit of water on here. You see it quickly goes all the way to the max. You see even like a little bit of water touching these pads makes them contact, and it maxes out the voltage. So even though technically this is an analog voltage sensor, really it's digital. It's 0 or it's 1. Like it's nothing or it's maxed. But it works quite well, and then you really have to dry it off. But then once it's dried off, it goes back down to 0, and then you want to set it off again. There you go. Okay. Water detecting. It's working.
And next
it's
up,
wet.
The star of the show, besides our community, our customers, our team at Adafruit, Ladyada is...
Okay, we've got finally, after many years, this is quite an old design, but I finally got it out. It's the Seesaw I2C encoder. So these are rotary encoders, which everyone loves, but they're kind of a pain to use. But I put them on a board with a Seesaw chip, a SAMD09, even a NeoPixel on there, and a little bit of support circuitry, and now you can plug it in and chain them over I2C. It's a very easy way to add a rotary encoder. Now this actually comes just as the PCB. Solder on your rotary encoder. We might have a version that's pre-assembled later, but basically you can connect up to 8 because there's 3 address pins on the back. Just select, just solder close a different jumper set for each one. Here's a demonstration of having 3 of them connected up. But it's like if you want to have a rotary encoder, it's like often very challenging to do. You can do it, but you have to deal with timers and pin interrupts and all that. This is over I2C. It works with Arduino. It works with CircuitPython. It works with Python. Very, very easy to use. So I can show on the overhead my little demo. Okay, so I've got here, this is my Feather M4, and I've got an OLED. And then, as I twist this, you can see this is just reading the number from here. All the pulse management and debouncing and even the NeoPixel timing stuff, that's all done over I2C using a couple commands. On the back, you can even see there's this little LED here. That goes off every time there's a movement, either a twist or a button press. Oh yeah, if I press the button, you can see P for press. So it's kind of all in one. It's nice 1 inch by 1 inch. Because rotary encoders rotate around all the way, like they don't have a stop. That's why it's at 45 degrees, so it would fit nicely in the PCB and not get in the way of anything. But it doesn't matter because once you put the knob on, you can't tell that it's angled. There's an interrupt output again if you don't want to pull I2C, because it's constantly asking I2C every 50 milliseconds, hey, is there any new data? But you can also use the interrupt pin if you want. And then, use it with anything with a STEM QT connector or I2C for very easy, very fast rotary encoder connectivity. It works with any rotary encoder with or without a switch. I happen to like the switch, but
and at a great price. Compare.
Yes.
Go out there and compare.
It's only a couple bucks. And then if people really like these, we can maybe offer a version that has a rotary encoder already soldered in. But we wanted to get these out to people real fast. And also, some people like detents, and some people don't like detents, and some people want 10 detents per rotation, some like 24. Pick and choose your favorite. But I'm really psyched because I've always loved rotary encoders, and I've always hated how hard they are to use. Every chip is a little bit different. CircuitPython makes it really easy. This demo's an Arduino, and it was a breeze. It only took a few minutes to get this demo together.
That's no problem. Okay, so we're going to do top secret, and go ahead and post up your questions. I have some
Post
lined
your
up.
questions, we'll do
and
them.
we're going to get out of here pretty fast. A couple minutes later than 9:15. I hope that's okay. This week, Ladyada, we had a lot of stuff to go over, but let's do top secret.
Okay.
So first up, top secret. We're going to just play these videos. There are upcoming camera things that are working on, and then we have a couple little surprises. So we'll see you on the other side. Okay, Ladyada, what is this?
Oh no, I'm trapped inside of this Grand Central. Help, help, get me out. No, just kidding. This is a camera that I'm testing out here, and this is me. It's pointed at me, and that's why I look like I'm in the screen. What's interesting about this is we're doing parallel image capture from this camera, this OV7670, through the Grand Central, and then displaying it onto this TFT, and it's like, 7-8 frames per second real time, all happening in CircuitPython. So we're actually getting the image capture and data being transferred through the CircuitPython core. We're going to be able to use cameras now for, of course, taking photos, but also for maybe machine learning or AI or image recognition projects using these really common OV7670 cameras. So this is SAMD51 parallel capture image support for cameras in CircuitPython. Hello, it's me. I'm so small, trapped inside of this little screen. You just showed off, we've got OV7670 support for CircuitPython on the SAMD51, but did you know that the RP2040 in the Raspberry Pi Pico can also read parallel cameras? This is 8-bit parallel data coming through an OV7670 parallel capture camera. We can use PIOs to do that, and we do. And this is actually all in CircuitPython. So you're watching me, my image being captured through the Pico in CircuitPython, and then that byte array being written out to the display over here over SPI. Now it's a little posterized. We're going to figure out exactly what's going on, but this is our first pull request, just testing it out for Jepler, and it looks really good, and it's pretty fast. So that's me in CircuitPython doing video.
Next up, we're working on a keyb. We got some
More
keybs.
keyboards. This is an RP2040 macro pad with 3x4 keys. It's got a 128x64 OLED or a TFT. I'm kind of like still deciding. And a rotary encoder. So it's kind of like a cute little I've seen a lot of these adorable macro pads, and I like the idea that like has a screen, has a rotary encoder, and like 12 keys that you can customize. These have socketed keys with NeoPixel, so you can pick whatever kind of MX compatible keys you like.
That's top secret.
Ooh, coming soon. Don't ask. It's not out yet.
All right, we're doing your questions. We do that over on Discord, adafruit.it/Discord. I have some loaded up,
Yep.
showing all 28,000 of us.
Okay.
Ready?
Yep.
I'm going to speed around these to you. Okay, for the Ion MPI chip that you showed, does the chip do battery fault detection?
It does. Check
Okay.
the data sheet for there's a fault output as well as I2C fault detection.
Does the device stay connected to the battery?
It doesn't have to, but the battery pretty much is, you really kind of want the battery to be next to the device and connected. But I guess you could disconnect it. It would just be like there's no battery. It would be weirded out.
Okay. Someone saw the NeoPixel trampoline video, and they're trying to do something similar with a spike ball net, but they want to be able to detach the net. Any tips on that right now? So I guess
I think just check out our weatherproof connectors, and then just have the NeoPixels, on a connector, like a quick connect, and then you would just connect it when you wanted to put the net away.
Okay. Next up, let's go to, is the Featherwing mini board compatible with ESP8266 or ESP32?
It should, but there may not be interrupt support.
Okay. Someone swapped out another vendor's server shield for ours, and it worked, and it reduced the current noise for their 6DOF robot. Thanks so much.
Yay, that's great.
Is there any good articles showing difference between CPython, MicroPython, CircuitPython? Yeah, the CircuitPython read the docs in the website CircuitPython.org.
Yeah, we have
has
a lot of
pretty good-
documentation in our repo and also our
Yeah,
GitHub, our
we get
essentials.
asked that,
Yeah.
so we do have that there. So check out CircuitPython.org.
Yeah,
scroll
even wrote a
down.
thing like, here's what you can expect.
Yeah.
And it's like, what from CPython, what do you expect?
Okay. Question for the show. Inspired by Apple's neatness, routing an Ethernet cable into the power brick, with Grove Quick taking off well for I2C, would it be a horrible idea if all industry went with a 10-pin Pico blade to route I2C and SPI for transmit and receive? Quick to Pico blade adapters could bridge those transitions.
Yeah, you can check out the video we did on this new connector that we're going to use called iSpy, which has SPI and I2C, and it has a bunch of extra control pins that you could, of course, do UART over. I will say most people don't really do like special UART connections, but that's kind of what we're going for. It uses the flex cable.
All right. I want to use the capacitor sensor, but what I want to do is several of them on a circuit playground. So I would want to have up to 8 of these. Okay, they only have 4 possible addresses, but I could use a seesaw to expand the address space. But how do I daisy chain one to another?
I posted on the forums. This is a very complicated question, and I think I'm not going to be able to answer it
Yeah, but
over
open it.
video. So post in the forums.
There's a solution, but probably the form
Yeah,
is
it depends
better.
on what you're doing exactly.
Okay, question on the water sensor detector. I know the plus is meant to go in the bus voltage to be powered. Is the milliamp draw low enough to be powered off in a different pin
Yeah,
to toggle?
sure.
the
It's
same
only a
energy?
couple milliamps. It's a single transistor circuit.
Okay, where do we get our PCBs from? Advanced Circuits, one of them. And
Yeah,
prototypes, we get them from everywhere. JL PCB, we did a...
Yeah, we did a video on
yeah.
that, so you can check that out.
Okay. Will the new product, the rotary encoder, work with index rotary encoders?
If it uses 2 pins and like the alternating toggle codes, then it'll work. Whatever is standard-ish rotary encoders, it'll work.
All right. Could you use a Pico for matrix keypads?
Yes, you can totally do that.
Okay. And then back to the rotary. Can you bridge the 3 interrupt pins?
Yes, they're pulled. They are pulled high, but pulled, and then they're yanked low by whatever is doing the interrupt. But you can also have them separate.
Okay. Would we be making any Linux compatible boards in the near future? And if we were, what would be the biggest hurdles for design?
I don't feel like there's
manufacturing?
anything I would design that isn't already being handled by the market. So I prefer just to carry what other people are making. They're doing a great job.
Yeah.
So let them do it.
I mean, the chips are getting fast enough where I could see people putting Linux on something that
Yeah.
go for it.
Yeah,
But-
go for it.
But like, Raspberry Pi 4 is really good.
really
Yeah. Okay.
Okay.
Yes, you could use a Pico or P2040 for a full keyboard controller. And then, yep. Scott is working on porting CircuitPython to native Python. Pi.
All right. Well, thanks,
I
everybody.
think those are it. You did the speed round.
Speed
Good work.
round.
Good work,
But I got
Ladyada.
to everybody.
You did.
Okay.
Are we going to watch Starship Flight today? We didn't get a chance to watch it, but I heard it landed. So,
Yay, space.
good
All right.
questions this week.
Thanks,
All
everybody.
right, everybody.
Good questions.
That was tonight's show. Special thanks to let me make sure Jessie May, who's in our chat behind the scenes at Adafruit. Special thanks to all of our team, especially the new folks who just joined.
Yay.
Adam, Serena, Robert, and then next week Letty. Congratulations for joining this adventure with us. We'll see everybody next week. Thank you all of our customers, all of our community, and all the folks doing good stuff and sharing with each other. We'll see everybody next week, 8 p.m. Here is your moment of Zener.
Good night.